All right, so hi class, how are you? So this is going to be a first of perhaps maybe 3 or 4 videos I'm going to do to help us prepare for the RQA. So we are going to look at the key characteristics and features of quadratics and exponential functions. We're going to practice writing quadratic equations based on graphs. We're going to also multiply polynomials and factor polynomials, in fact, and then add and subtract polynomials. So we're going to get started with this graph here, and we want to identify the key features, right? So I'm listing the key features. However, for instance, if it didn't have all these features, you could say, okay, I want to figure out something else, and that could also be one of them. But the key features usually are the vertex, the line of symmetry, domain and range, in this case, max or min, and then perhaps the intervals, at least the ones that we're going to focus on today. All right, so the vertex. So the vertex is where the highest or the lowest point of the parabola, right? It's where one side sort of meets the other side of, to a degree. And so we can notice here that we have a max because in fact, it is the highest point of the parabola. So the max is the same as the vertex. So I have -2 for my x and I have 4 for my y. So that is the vertex for this parabola. Okay, the line of symmetry is the same as my x value. So I'm just going to change colors and sort of draw in this line of symmetry. Right, it goes through the x-axis, and so we write it as x equals -2. That's the equation for the line of symmetry. Okay, so again, if I switch colors again here, let's see, I can do black. I'm going to just draw the arrows because sometimes this helps us sort of visualize that we're on like a roller coaster, right? This parabola is like at Six Flags, and we're riding up and down the roller coaster. Okay. In reality, this is going to help us here in that the arrows are going to go down this way, right? Later on, we talk about our domain. So if I want to see where is it increasing, well, I'm going up, up, up from -infinity because this arrow doesn't stop here, from -infinity. And I put a sort of a parentheses around here instead of a bracket, to -2, right? Because that's where on the x-axis, not the y-axis, but on the x-axis is where I start going back down. So I'm going to include -2 here. And then, this is sort of, I'm going to actually include -2 here too, even though in reality, I probably couldn't because I can't include it in 2 places, but we're going to include it right now because at this point, it's going to start going down again. -2, it goes down until positive infinity, right? So positive infinity or negative infinity all the way up to -2, or you can look at it this way. -infinity up to -2, and then from this point it starts going down again, if it helps you to sort of visualize it more horizontally than this way. All right, so we already talked about the max. The max is the same as the vertex. In this case is -2, 4. The range, and this is where I'm just going to clear off a few things here because it's getting cluttered. The range represents all of our y values of the graph, right? And so again, I'm going to include this arrow, all the y values. Well, it looks like it does have an endpoint, right? It stops at 4. So y would be everything less than yet equal to 4. It includes 4 and everything less than that. So I could write that a number of ways. I could write it as y is less than and equal to 4. I could write that as a compound inequality with 4 is greater than or equal to y, which is greater than or equal to -infinity. And I don't know, I probably could write it just as an interval notation too, right? So then domain, well, I included these arrows, so that tells me this is all real numbers. So we have not yet seen or dealt with the parabola that did not have a domain of all real numbers. We will, but not in this unit. All right, so the next question here is, what is the equation for this vertex or for this parabola? And this is something that I'm going to be talking about more in class, but it's going to help us a lot to understand this. So we've already talked about the roots. Oh, that's another thing I didn't include. So in fact, we can identify the roots or solutions. That's something we need to do that as well for this, but we'll just do it on this one because it's the same graph. So we're going to find the roots of this parabola or the solutions. Remember, they are the same thing. So I know -4, 0 is 1, right? And the other is the origin 0, 0. Now, one thing we haven't learned, but we are going to learn now, is that when we write the equation in factored form, the quadratic equation in factor form, we're really just referring to the roots. We're referring to the x values within the roots. So I'm going to write that as, well, let's not forget a. Often we don't necessarily know what the a is, but we could, right? And then I have x something, and then x something here. Well, in this case, I know that I could have 0, right? So it doesn't even matter. I can add 0 or I can subtract 0. It does not matter. So let's just say we're going to add 0 here. So had to pause here. So we have 0. It could be plus or minus. It's not going to change my value, but I know that this is right? Because that is one of my x-intercepts or one of my solutions. The other is a -4, right? So if I have a -4 here, I'm going to write that as a positive. Remember how we did that before, right? We said if we had our solutions -4, 0, and let's say if we had, let's say in this case it was 2, 0, right? Those are our solutions. Then this case would be a positive rather, and this one would be a negative because, again, this is where we've been challenged, is really understanding that when our equation was always written in additive form, and so this becomes a addition problem because you're subtracting a negative. Okay, so now let's get to the a. We got this far. We know that we got our x's, we got our roots, all that's in. Now let's figure out what our a is. So again, the a is the dilation. All right, so the dilation looks from this point to this point. That's really all I want to know, is that first point, from the vertex to the first point. So I go down 1 over 1, right? And I do the same here just to double check. I go down 1 over 1. So again, this is going to be a negative, right? In this situation, it's negative, a -1. So I'm going to rewrite that as -1 times x plus 4 times x plus 0. And again, it could be -0 because it is 0. So we're going to do one more like that. Okay, so now we have an upward facing parabola, right? So I know that I'm going to have a min in this situation. I know my vertex, let's see, it looks like it is right here. So I'm not going to say it's at 0. It looks like it's probably going to be at, if that is 1, so that would be at half, right? So I'm going to say half is my x value. -1/2 rather, and then my I'm going to actually say it's on the -6 for the y value. So this is my vertex, which means it's also my min. The line of symmetry is my x value, and again, I'm just going to draw that in. Let's see, sort of sketch it in here. All right, so that's x again equals -1/2. And this is a little different because it is a upward facing. So the increasing and decreasing are going to be switched, right? Because it starts by going down. It starts by going down. And then when it gets to this -1/2, it shifts and then starts to go back up. So I would write it is increasing from negative 1/2 to positive infinity. It is decreasing from negative infinity to negative 1/2. All right, so the range again, it looks, because it is upward facing, it's going to be y is greater than, right? Y is going to be greater than whatever this value is. So it looks like, again, we said it was 6. So y is greater than and equal to negative 6. And as I mentioned, our domain is all real numbers. Okay. So we're going to do another equation based on this. So we're going to look again for our roots. So our roots in the situation, I'm going to put a dot here at, it's counting by twos, or counting that, well, it's counting by ones, but only numbering the even one. So that's going to be a negative 3, comma 0. And this one is 2, comma 0. So again, remember, for my equation, I'm going to make this a positive 3. So I'm going to write that as x plus 3. And when we work a little bit more on solving equations, it's going to make a little bit of sense, because it's going to be something like this: x equals negative 3. Well, if I plug it back in this equation, it will be x plus 3. And so that's going to help us a little later on. But for now, we're going to just understand that I'm going to put this as a positive, or an addition problem. And here I'm going to do x minus 2. Right? But I can't forget about my a, right? So I need to figure out, what is the dilation here? How is it? Is it narrower or is it wider than my parent function? So I'm looking at this and I can tell it is going to be a little bit more narrow than my parent function. So that means this is going to be greater than 1. It's going to be greater than 1. And normally we've just been dealing with 1, right? And then we just sort of ignored it. We didn't have really an a that we cared about. But this time we are, because it's narrower than the parent function. So I'm starting here, again, at my line of symmetry. And I'm going to do a little guess and check here. So I notice right away that if I go up 1, I go over, it does not hit it hits the graph, but it doesn't have a clear point on the coordinate, right? It's not a whole number as a coordinate. So that's not really helpful. So now I'm going to go up again and then go over. And I notice this time it does clearly hit the graph. So again, I'm going to check here. I go over. It's at a halfway point, not clearly. Remember, we always sort of want these nice, clear numbers for our coordinates. And so again, it nicely hits the graph. So what does that tell me? Well, I know it's going to be positive, right? Because it's upward facing. And I also know that the dilation is 1, 2, because I had to go up 1, 2 in order for me to hit the graph from the vertex. So I would write that as 2 x plus 3 times x minus 2. Okay, this is in factored form, right? And I can actually add f of x is equal to all this. Okay, hopefully this is useful. I will be making other videos, so talk to you later. Bye.